Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. So for today's lesson, we're gonna do the applications of differentiation. So for your level, you're gonna have to know these four major points. But today we're gonna discuss the first and the second one. So in this section, we're gonna discuss about stationary points. So for this section, you need to know how to find the stationary points. You need to know how to find the nature of the stationary points, and then you need to know how to sketch the graph. So briefly, I'm going to explain about the stationary points. You already know about this. Okay, so if you differentiate the function dy over dx, you will get the gradient of the tangent at point x. So for example, if I have this function fx, if you differentiate, you'll get the gradient of fx at point x, for example, at this point, or this point, or this point. If you want to find the specific gradient, you have to substitute the coordinate of x here. Okay? So that's dy over dx. So if your dy over dx equals to 0, meaning your gradient equals to 0, so you're going to have stationary points. So you have three types of stationary point. You have maximum, minimum, and point of inflection. So point of inflection is when the function is increasing and decreasing, then it stops at stationary point and then it keeps on decreasing, or increasing, it stops at stationary point and then keep on increasing. You know about maximum or minimum. Okay, so how can we tell the nature of the stationary point? You can find the nature by finding the second differentiation. You have to differentiate second time. If it's greater than 0 or positive, then you have a minimum point. If it's less than 0 or negative, you're gonna have maximum point. Okay, so sometimes you'll get 0, which means inconclusive, which means we cannot tell whether it's a minimum or maximum. So how do we find the nature? You have to investigate further using a table method, which we will do on the next example. So just have a read and try to understand this. So I'm gonna skip this example. I want to explain the next example, which is exactly the same, right? So this is an example that I want to discuss with you guys. So let's say we have this function y equals to 12x to the power 5 plus 5x to the power 6 plus 1. They want you to find the stationary points, the nature, and then they want you to sketch the graph. So this covers all the lesson objectives of this section, right? So for stationary points, you know that dy over dx equals to 0. So I want you to always write this statement when you want to find the stationary points. Then you need to find the dy over dx, which is just a simple differentiation. Simplify it, you'll get 2x to the power 4 plus x to the power 5. So this is weird, huh? We never learned this, but you can use common factorization to solve it. So take out x to the power 4, you get this. So x to the power 4 equals to 0. How do you solve this? Power of 4, you bring to the side, becomes 1 over 4. 0 to the power of 1 over 4 is equals to 0. So x equals to 0. So 2x plus 2 plus x equals to 0, x equals to minus 2. So I have two stationary points. Then you find the corresponding y coordinate. In the end, you get these two stationary points. If I want to plot this on a graph, just simple sketching, I'll get something like this. This is not a true scaling, huh? It's just a general sketching, but make sure you sketch it appropriately. Alright, so just leave it at that for a while. Next, you want to find the nature. How do you find the nature? Using second differentiation test. So you have dy over dx. If you differentiate this further, I get d square y over dx square. Right, so for the first point, this one, when x equals to 0, when I substitute it into d square y over dx square, I get 0. So this means that the test is inconclusive because it cannot tell you whether it's a minimum or maximum stationary points. So I'm going to have to use a further investigation using table method. So like this one. So you build a table. So this column is x and its gradient dy over dx. Then you start with 0 here. So when you substitute 0 inside your dy over dx, not d square y over dx square, okay, dy over dx, because this test is failed, it's inconclusive, so you have to use the gradient dy over dx. If you substitute 0 inside your dy over dx, you know you're going to get 0, which means a stationary point, which means a flat gradient. Okay, so on the left side, you're going to have to choose one number which is slightly below 0. Make sure it doesn't exceed -2 here, right? Or else you'll be disturbing the second stationary point. So just choose between 0, below 0, but no more than, not less than -2. So I choose -1. When I substitute into this dy of dx, I get a positive number. You can use your calculator to find it. So which means if dy over dx, if gradient is positive, which means it's an increasing gradient. Okay, so on the right side, I want to choose a slightly above 0, which is 1. Substitute that, I get positive, which means increasing function. So if you look at this shape, this is actually an inflection point where it decreases and then it stops and then it increasing again. Increase, stop, and increase. So this is an inflection point. So done with this one. So let's investigate the second stationary point using d square y over dx square. Substitute -2. We get 480, which is greater than 0. So if your second differentiation is greater than 0, it means that it is a minimum point. Okay, so with that information, we can try and sketch the graph. So for the first point, it's an inflection point. So we have an increasing gradient, then it stops, then it increasing again. So for the second point here, it's a minimum, so you're going to have something like this, right? So just connect the graph together, you'll have this type of graph. Of course, you have to draw it properly. Okay, done. So you can try example 1 and example 3. It's exactly the same. All right. So next we're going to discuss about increasing and decreasing functions, which they always ask in exam. All right. So briefly, so what is an increasing or decreasing function? A function is increasing if the gradient keeps on increasing, which means dy over dx is greater than 0. So and vice versa for decreasing. So let's look at this function fx. Let's look at the left side here. So you have function fx here. So this function is decreasing if the gradient here, look at the gradient here, keeps on increasing. Okay, so dy over dx or f dash x. Alright, so if you look at on the right hand side here, fx is decreasing, then you know the gradient will always be decreasing. Right, so that's it. Okay, so let's try do this example. So example 4, find the range values of x. You need to find x for which this function is increasing. Okay, so we know that the function is increasing if dy over dx is greater than 0. We need to find the x. So dy over dx, you differentiate, you get this, and then you put greater than 0. Then you solve this. Then you get your values of x. So what is this? This is not an equation, this is quadratic inequality, so you have to solve it appropriately using side workings. Don't solve it like an equation. Okay, so refer to your notes, you get your answer. X is less than -4 or x is greater than 2/3. What this means is the function y is increasing when x is less than -4 or x is greater than 2/3. Now this is not the diagram of fx, okay? This is our side working to solve quadratic inequalities. Alright, so we're done here, finish. But if you want to analyze and understand it, let's try and draw the graph. If you draw this graph, like example 1 to 3, find the stationary point, find the nature and solve, you'll get this one. I'm using GeoGebra to draw this. So this is my stationary point, x equals to -4, this is 2/3. This is the function of fx. If you look at this, if your x is less than minus 4, which is this part, you see the diagram is increasing, right? So this statement is correct. Y is increasing when x is less than minus 4. More than minus 4, the graph decreases, right? And then after 2 over 3 here, the graph increases back. So this is correct. The statement is then therefore correct, where f is increasing when x is less than minus 4 or greater than 2 over 3. Alright? So you don't need to draw your diagram in exam because they don't ask you to draw it. So just use this solution. But you can still draw it, but you're gonna waste a lot of time here. Okay? Alright, so this is another way they can ask you in exam. So it is given that fx blah 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 for x belongs to real number. Show that f is an increasing function. Now they want you to show that f is an increasing function. They don't ask you to find x. Okay? So it's a bit different from example 4. So we know that for increasing function that dy over dx is greater than 0. So to prove that f is an increasing function, you have to find dy over dx. Then you're gonna have to prove it that it's always going to be greater than 0. So you're going to have to investigate and do some analysis here. So in this case, we have to use f dash because the question they use fx. So differentiate it, you get this one, composite function, 6 bracket 2x minus 5 bracket square plus 1. So let's investigate this. Right, so this one. So if you look at 2x minus 5 square here, this part, it's always going to be positive. You know why? Because of the square. If you substitute any number, if it's positive, you square it, it will become a bigger positive. If it's negative, you square it, it will be positive. So this part will always be positive. This is a common sense, okay? Like modulus, but you have square. So if you multiply that positive number by 6, it's going to be a bigger positive number. You plus 1 again, it's always going to be another bigger positive number. So therefore, your f dash x, which is dy of dx, is always going to be positive, always going to be bigger than 0. Right? So therefore, fx is an increasing function. That's it. Right? So if you want to investigate this further, right? So again, look at this part, 2x minus 5. The smallest number that you can have is 0. Is when x equals to 5 over 2. Substitute 5 over 2, you'll get 0. 0 squared will become 0. Now 0 you multiply with 6, you'll get 0. You plus 1, you will get 1. So again, your f dash x, your dy over dx, your gradient, the smallest number it can take is 1. So which means that fx is always going to be greater than 0. So it's going to be positive. So if your dy over dx, your f dash x is always greater than 0, it means that your fx is increasing function. Okay, so try to understand the difference of example 4 and 5. Right, there's a lot of examples in your past year paper asking this type of question. If you can do this, then you can do the past year question. Alright, the second part is about equations of tangents and normal. So this belongs to coordinate geometry. We're just gonna have to use the extra information on dy over dx. This is very easy, okay? Alright, so you can try and read this question, this example. This is very straightforward. You know how to do this from coordinate geometry. There are just some additional points on dy over dx. So try and understand this and redo it and then do some of the assignment. Always try to sketch, because the sketch, as I said, can help you a lot. Visual aid, right?